think I'll feel a whole lot better. You'll thank me, you'll thank me. My mind's telling me no. But my body tell me yeah. Anyway, brother. Sorry, I know it's kind of gross. I just swallowed on the mic. You're gonna have to make that concession, okay, guys? Because I'm trying out these clip-on mics. They're way more convenient. I don't have to like lean over into the USB mic. So try to be gentle with the noises, okay? But yeah, bear with me because this is way better. Yeah. So anyway, I got my new office set up to some degree. Now I got it's pretty sick, brother. I got now I don't know who. I shouldn't have put the desk right here. Like I literally can't even. Well, whatever. But so I got a pool view. We're on the top floor. Got the sunlight, natural light, baby. Good times. Life is good. Life is good. But anyway, this is our last week. Well, we're coming up on the last week where I'm gonna have well, when I'll not be working, right? So I started the stream. If you've been following me since the beginning, I was laid off in February, and then got my job in May. Anyway, I start in July, so this is our last week. So I'm telling you that just because I'm not exactly sure what I'm gonna do with the schedule. I still want to get it out every day, though. I'm just trying to think of something reasonable, or maybe every other day, something like that, or just really long Swift streams on the weekends, which would also be doable. If anyone has any feedback there, I kind of feel like the programming, that kind of stuff is better suited to be long form, like even longer than we normally do. Like right now, 3 hours is maybe long, but what if I did Saturday, Sunday, 2 5-hour streams? You know what I mean? So if anyone has any opinions on that, even one single opinion would help. But I'm kind of leaning towards that. I think just because learning this kind of stuff is so meticulous, and you really need to, at least for me, it's hard to take too small of a bite each time. Because then I don't know, just the continuity, there's not big enough concepts there. But I don't know, we'll see. Yeah. But other than that, welcome if it's your first time here. We were on a quick little hiatus, but now we're back. So as far as you're concerned, for now, this is still a daily stream. But yeah, so we started working through this book here. It's a great book on SwiftUI, and we got through the first chapter. So we're not going to go back through it, although I'm kind of fuzzy on where we were. But we're just going to get started. So we just now started this, so a lot of it is very basic, and we're just learning concepts. So I think it's fine for now, but yeah, it should be fine. Because the only thing, actually, I just need to see the name of yeah, okay. The model, okay, so that's what we went through. So we did this last time. Let's see if there's anything specific I need to remember. It doesn't really look like it. Okay, so I guess these are the main new things. Swift data we've never imported before, so we finally started working with that. And then the at model macro. Okay. Yeah, so now we're setting up stuff that we've learned the concepts for, which was, if we go back, model container, model context, and the view. So now we're like we learned about these. So if you want to go back to episode 56, I think is when we learned about these. But yeah, no, that's right. That's right. Yeah, because this is just basically the model is your schema, your types. Model container is a framework, a bunch of different tools that Swift data gives us to work with data. So it reads the schema, stores data, so it's writing to disk. It actually has the whatever the implementations are that write to disk. That's what we're actually calling in Swift data. And then there's also this this data loading piece where it's writing it into memory once we initialize the app. And then there's the context, which we learned the context is just everything in memory effectively. It's a spot in memory allocated for the app itself. And then the view. So then, yeah, so we just went through first example, which was the model. There's our schema. But I mean, aside from importing it and using the macro, this is a pretty familiar looking class that we saw while we learned Swift proper. So I mean, syntactically, it's not all that different. Or it's not different at all. It's just this decorator, actually. Yeah, it's not. I mean, this would be a valid class just in Swift proper as well. Okay, so then model type supported. What kind of types can I store in a model? Bool, data, date, decimal, double, float, int, string, URL, UUID. Arrays, enum, structs. Okay, so damn near everything. I don't know what was excluded there, but unsigned, is that? Yeah, so like uint would be something that's not on this list, but that's not necessarily something I would need, I don't think. Okay, so you added a file. We did this part too. Okay, here we were. So this is where we'll pick up here. The model container, first example. It's time to set up your model container. A common practice is to create your model container when your app starts or when you first need data. And you probably want to keep it alive for the life of your app or the life of the views that need it. So you don't have to keep creating it. Okay, makes sense. For this example, we will add the model container to the app file. Add the model container to the app file. Okay. Remember, the model container is the toolbox that sets up Swift data to be used with your app. So setting up Swift data in the app file is common. Let's update this file on the next page. Okay, so we'll add the model container to the app file. This is the entry point of your app. Okay. Remember, the model container is the toolbox that sets up Swift data to be used. Okay, so it's the entry point, so it makes sense that it's there. Gotcha. All right, starting as simply as possible, you only need to use the model container modifier and define which model you want to use. Okay, let me swap over. Oh God, what happened? That was weird. Yeah, so I changed my setup a little. Hopefully this is just as well because it's way better for me. I'm hoping it's equally, the viewing experience that it was for y'all, but I'm actually on my iPad remoting into my Mac, but this lets me use the apps on the iPad. So this is the Books app, but it's way better in terms of like I can do stuff like this now, punch in and look at stuff. And eventually, I know I keep talking about it, but it's coming, trust me. The more we fill out our boards, I just think I'm going to need to be able to zoom into a lot of things because any tool that I'm using for the stream and whatnot is like an infinite canvas type of app. And so to be able to punch in to any of the vector stuff, it'll still look really clean. And it's like a cheat code. It makes it a lot easier to work with. Lots of stuff if I can just pan the screen. But yeah, anyway, that being said, I need to go back here. This is the only annoying part that I'll have to just kind of deal with. I think, yeah, I can't copy that text. Okay, so what did you want me to do? Starting as simply as possible, you only need to use the model container modifier and define which model you want to use. You will need to import Swift Data Framework. So this is what we just read. I'll go back to the book. I just need to keep up with the example here. So first example view. Wait, so first example app.swift. Oh, you want me to create file? Or is it already there? Oh, I think I just made that file name. Oh, that's right. Oh, yeah, because I called it something different, but that's no big deal. So you want me to do this here? Yeah. Gotta be here. Okay, so import Swift data. And first example view, window group, content view. There's an example. She's picking that up. What is the problem? Cannot find. Oh, that's what I was trying to fix, man. Because this had, yeah. So I guess I didn't follow the instructions there because it's not what I got, but okay, so first example. Okay. Okay, now it's working. All right, and then there we go. Oh, okay, never mind. It's a bad idea. Just show me where to. Okay, model container for person beneath the first example view. Just a modifier for that, okay. It's very explicit. Person model, not self. Okay, so we imported, setting up the model container is just one modifier. Setting the person model to first example view allows you to work with this model within it. Setting the person model to first example view. It's going to work with this model within it, and any view first example view navigates to. Okay, so we get to work with person model, okay? And any view. Oh, and any view that it navigates to. Okay, sweet. Oh, sick. So like you can, okay. So for each top level view, any top level view and any path that you set up that would begin from that top level view, we can also work with. That's pretty cool. To expand the availability of the model container, you can move the modifier to the window group. Okay. Note, setting the scope for the model container is just like how you set the scope of the environment modifier. More information referred to book. Okay. Question, what is this modifier actually doing? That's a good question. This modifier is telling Swift Data to create our permanent storage, if not already there. Create this model, person model, in our permanent storage, if it's not already there. Load the model into the model context and add the model context to the environment of the view or window group it is attached to. Add the model context to the environment of the, okay. Can I add more than one model using model container? Yes, you will see more examples later. Okay. All right, we have our model defined and we created our model container. The next step is to set up the model context in a way that our views can use it. All right. In the previous section, you learned that the model container modifier added the model context to the environment, so your views can now access it. Why do you even need the model context, though? The model context is needed to do Swift data operations on the data that is retrieved. To do Swift data operations on the data that is retrieved from memory. Yeah, you gotta know the shape of it, otherwise how can you work with it? You gotta know how it's coming to you, such as updating or deleting it or inserting more data. Okay. Yeah, there's a really cool project I got to work on when I was in my brief stint in DevOps. We're working with a file format called Parquet. It's not new at this point. It's been around for a hot minute, but it's pretty cool. It's columnar in terms of its structure, like on disk. And so in effect, the whole idea is if you store data in your persistent storage, like on disk, if you store it in the same way that you work with it in memory, then you don't have to do this encode decode, which since a lot of our services now are web-based services, so almost everything is in the cloud. So that means almost everything is, making network calls, and in each of those exchanges, anytime you're loading data either into memory or working with data, transforming it, and then writing back to disk, there's always this serialization, deserialization process that has to occur. But that's only because the two formats are different. So it's different. It's stored in a different format than it is used and worked with in memory. But with Parquet, and this was mainly to solve a lot of issues with with big data, like if you've ever worked with a framework like Spark, big data pipelines, stuff like that. So anyway, some really smart people got together, figured out this format, and so now there's basically SDKs now for almost every, like I was using the one for Golang and Python, but there's a Parquet library for almost everything now, even Swift. So but yeah, this is what made me think of that. I wonder. Well, I guess we'll see later. Okay, the model context is needed to do Swift data operations on the data that is retrieved. Oh, that's what I was going to say. Yeah, but so what's interesting about Parquet, it was like 800% less size. Like I want to say I had a text file that was like a gig compressed to CSV, and that same file with like Parquet is like 5 meg. Like, wait, in order of magnitude. I don't know how many orders. I don't even know what that really means, brother. But I'm just saying it's exponentially. How about that? Because I know what that means. Exponentially smaller than CSV. So that's really the benefit, the performance gain, because you're not serializing, deserializing, and then also the actual compression of it is it's just far superior in terms of pure storage anyway. So what would normally be a gig of data could be shrunken down to like 5 meg if you use Parquet versus text or CSV or whatever. That's really the two main benefits, which are huge. So you think about companies that all they do is cloud, so you're paying for way less data to just sit there in terms of your storage, and then you're also using less less bandwidth. So your overall cost is going to go down as well, and performance should go up. So yeah, as long as you have the right tools to convert, and they're pretty available now, it's really no reason not to do that, other than obviously it's going to cost to implement it. But aside from that, you should be able to pay for itself pretty quickly. Okay. The model context is needed to do Swift data operations on the data that is retrieved, such as updating, deleting it, or inserting more data. Update the view. Okay, we're back to Xcode. I guess it's closing in the background. Not sure why, but it is. It's annoying. Wonder if it's timing out after. That must be what it's doing. But okay, so update the view. Why is it only? Oh, I got the wrong mouse. Or Xcode won't let me do it. Weird, it can't. I guess it can't shrink any more than that. Okay, fine. All right, so update the view. Okay, now you have a Swift data model. Model container setup. What is happening? This means Swift data has enough to create a persistent store. You can now insert data into the persistent store. Let's do that next. Okay. Oops. Speak Swift data has enough to create persistent store. And what to do? First example view. It's like uneven right there. Oops. Okay, import SwiftUI. First I will view VStack. Image, yep. Globe, okay. Image scale, foreground. Text, hello world, padding. It's all the same, brother. Yes, I can confirm my preview works. We go on. Sheesh. Okay, great. All right, so then what? Views folder, okay, we're there. Model context is in the environment. So you access the model context through the @environment property wrapper. Import Swift data. That's our view. So what are we adding? @environment, escape character, model context. Oh, geez. That's all a decorator? Okay. Private var. Got a new method called the .insert. All right, the environment property wrapper provides a special path just for your model context. You will have to import Swift data. This model context has a value because the model container modifier you added in the previous step added it. This model context has a value because the model container modifier. Oh, okay. All this button does is get a random name and uses it when creating a new person model. It is then inserted using the model context. I see, okay. It will then automatically get saved to the persistent store. Note, the only reason we needed to access the model context in this example is because we needed to access one of its Swift data operations, which is insert. If you don't need to perform any data operations, then you do not need to access the model context. Okay. So, Swift data. Wait, what? You want me to get rid of all this stuff? I guess that's... First example. Oh, no, it's above here. Okay, my bad. I see now. Okay, so now our environment. Model context. Private var. So inaccessible except from within this view model. All right. And guess we are getting rid of all that. Okay. All right, so 4. Button. Add person. You know, it's crazy. A lot of the apps, there's a lot of apps on the App Store. Some are even, I would even call them not shit. Like they're decent apps. But it's just a bunch of collection of these, and like I can see how. What am I trying to say? It just goes to show, like if you have even a decent representation and can write functions, you can still do a lot. Because a lot of people will make apps like this. Just imagine a bunch of these little buttons. And I guess it's more for like technical people, because I don't know that a lot of people would go searching for them. But you know, there'll be a bunch of different, kind of like a launch pad. Like you think about like this keypad has a bunch of different buttons, but a digital version. So like every button that you hit does some different function, like you know, print the screen, or open my photo editor, or make a copy of something. But yeah, it's crazy how it's just so easy, like to make a button pop up on screen now. So this is cool. This is web level easy. So okay, where was I before I started yapping? Oops, no, come back. Let name equal this array of strings. Mark lim. What kind of name is that? Sorry to anybody named Lim. Lim Chase. Not because it's a bad name. I just mean if you happen to be named. Not trying to be mean. Random element. This is a force unwrap of an optional that person passing name to name. So one of these, oh, okay, random element out of Mark Lim or Mark Lim or Chase. Hey Lim, how you doing, buddy? Okay, person, model, name, and model context dot insert frozen person. Yeah. Okay. Cool. Okay. All right. So now the only reason we need to access, if you don't need to. Oh right. Okay. We read that. Okay. So all we did was just write that code. Okay. So what's next? The model container is created, and the model context is added to the environment. Cool. Now the view has to access the model context so it can get some data and display it on the screen. Now the view has to access the model context so we can get some data and display it on the screen. Okay. So now we're binding the data values in the model context, aka in memory, to the view. But I guess the way they describe it, I guess it's more of a pull, not a push. Not that it necessarily matters, but just so we are thinking about it correctly. The view with Swift data set up, it is now time to get some data objects to display on the screen. query concept. The view is going to use a property wrapper. Actually, that does make sense because that would be the client, just like in the web. So it makes sense that you would be doing that. And that it's a pool. Yeah. But in terms of like what triggers it to update, push or pull, but whatever, it doesn't matter. Okay, so the view is going to use a property wrapper called @query to retrieve data from the model context that was added to the environment. The request is passed from the view to the model context. The view is going to use a property wrapper to retrieve data that was added to the environment. The request is passed from the view to the model context. Okay. The request is passed on to, oh wait, oh, it starts here. Okay, the view @query I need data. It's passed to the persistent store and loads the context with the data requested. But even this diagram is not entirely accurate. Okay. Query pipeline concept. The previous diagram gives you the idea a query for data is made, data is returned, and that is it. It did. But really, when the query is used, it is like setting up a pipeline. So whenever data changes in the model context, the view automatically gets updated. This is because all models are observable. Oh, okay. Yeah, so we did, it was pretty straightforward even in, oh boy, pardon me. Oh man. I'm just stretching here. I'm not gearing up for like a whiteboard session. Don't worry. Oh man. No, but we did cover that. I forget the word already. I think it was, maybe it was observable. But we did it in Swift in one of the last chapters of the Big Nerd Range Guide. So yeah, if you want to see how they implemented that, we did a few of those examples, but you know. But yeah, okay, so at least I know what they're talking about. I never got the whole, like the reactive stuff with web, I thought was pretty straightforward with Svelte. I never got into React. I didn't want to. I don't know how easy or complicated it is there, but yeah, the whole RxJS thing, like using that straight out, man, I'm just glad to have the tools I have available to me now because it seemed rough. Okay, but anyway, I need data, yeah, okay, so then it passes you along. Sets up a channel basically. Now whenever the data in the model context changes, those changes are automatically sent down the pipeline and the view is updated. Okay. I guess just for any fields, or I don't know what you call it, elements that are in the context. But okay, but that makes sense. So you query it once, you're not making isolated calls. You do it once and then it sets up a pipeline. Okay. @query. Now add the @query to get data. Then then a list to display the data it gets back. Can we play this? Oh, that's what we're going to be able to. Cool. Okay. Now, let's see. Add the query to get data, then a list to display data back. It's not very exciting. We will add data on the next page. The model container created a model context and added it to the environment. The query accesses the model context and requests person model objects. Because of built-in observation, when new model objects are inserted, deleted, or changed, the view is updated automatically. What is amazing about this code is the type you set on query person model is all you have to do, so Swift Data knows that data you want from the context. So Swift Data knows what data you want from the context. It's that simple. Yeah, that's crazy. Maybe AI will take all our jobs. Why is there no ID specified for the list view? Need to write this code first though. Okay. Is there like a timeline? Oh well. We did that part. Okay, here we go. Okay, so first example view, the environment, and then below the environment, we add our query. Hold on, don't want to cough in your ear. Let me. Testing 1, 2. Okay. All right. So then, now that I am alive again, query. You know, I wish they'd make a 16-inch iPad, and this would be perfect. But I'll have to smooth this out a bit. All right. So query private var people. Person log. Okay. Oh, that's it? Wait, it's not it. Add person, let. Oh, the list. The list. Button, insert person. Oh, I got this on the. That's why it looks weird. B $, X. Here is the list. List people. Trailing closure. Syntax. Person in. For every person in a text view. Or render every. Wait. Yeah, render every person as a text. Render inside of person.name. And person equals. Oh, the model. Which has the array. Okay. Text person.name. Two. What's the problem? You. Why don't I have the button? The button is in the VStack. Oh, that's what I'm missing. I don't have a VStack. Okay. Yes. Gonna be the $. There we go. X P. Okay, cool. So now what? 2 and 2, is that right? I didn't mean to do that. Don't want to do it. I think I started the simulator. I was just trying to format the code. I wish it would. Can it not do that? Really? Okay. Never mind. All right. So we got that there. Yeah, is it working? We don't know yet. I don't think we added the other part. Okay, so we just added the query. Why is there no ID specified for the list view? When you use list, you sometimes have to specify a key path to an ID. You've probably seen code similar to this before. List, people, ID, self. Yeah. You don't have to do this if your items conform to identifiable, though, the protocol. The good news is Swift Data automatically makes your models conform to it. Wow. So it does it for you. So you never have to specify the ID. Dang. Spoiled, man. Okay, so now you know that not only are your models automatically made observable, reactive, but they're also identifiable. That's freaking awesome. Okay. My preview is crashing. Why? When you run the app on the previous page, it runs and works fine. If you try to run it in the preview and tap add person, it'll crash. Mine didn't crash. Maybe I gotta build it again. That's awesome. Guess I'm a dev now, brother. All right, so okay, but mine's working, not crashing. So what did I skip ahead? So we were here. Okay, no, so it's working at this point. So we're still, now we're here. But that's not a code change. That's just explaining why we don't have to give an index and then, oh, okay, I guess after this change. That makes sense. First example view. Okay, I'll make this change and then we'll go read the slide. Yeah, relax, brother. We'll get there. So, okay, so model container or what is person model.self? How far can I Okay, what is it? The self notation refers to the type of a class rather than the class itself. The dot self notation refers to the type of a class. The type of a class. Okay. Rather than the class itself. So now that's 3 uses of self that we've seen. So there's capital S self, which is for protocol types. Or that's reserved for working with protocols, so that's the only place that you'll see it. And then there's little self, like for properties where we refer to whatever the instance is. And then I guess now this, trailing a class dot self refers to the type rather than the class. Not sure what they mean by that, but I'm sure he'll show us. So. Okay, so we make that change, person model.self. Like, I guess they're saying, like, if this was a class, it wouldn't refer to this, but instead type, which this is a protocol, but it would look similar. Why though? Okay, so here, refresh, add. It's still working. Model container for, When you run the app on the previous page, it runs and works fine, but if you try to run it in the preview and tap the add person button, it'll crash. Why? Remember earlier when you learned about, why am I reading it on this tiny ass? Okay, remember earlier when you learned about using the model container modifier to add model context into the environment? Well, when working with previews, this model container modifier has to be added to your view too. Oh, I guess I skipped ahead. I don't know, but we already did that, so that's why it's working. Okay. Yeah. Get to add it to the view. Otherwise, there will be no model context in the environment. Don't worry too much about this right now. The next chapter will teach you all about this and how to show mock data in your preview and how to test with temporary data that does not get persisted. All right. Questions and answers. The query didn't have to somehow connect to the model context that, oh, this is a question. The query didn't have to somehow connect to the model context that is in the environment. The query is so smart that it automatically looks for the model context in the environment. Okay. That's cool. So you have to think around with like some kind of config for connection to the context or something. So they're saving us some boilerplate, perhaps. If no model container modifier was used, then Xcode debugger console will say set a model context in the view's environment to use query. Okay. How did the view update automatically when new people were created? All we did was call model context.insert. So how did the view update? Because it is observable. The query receives notifications from the model context. Remember, your model is observable. When a model's data changes, it tells the model context and query gets notified, and the view is redrawn to show new data. Yep. I wonder if it's doing kind of like with like in the JavaScript space, there's been this migration to islands, if you're familiar. Like if you can imagine what we're looking at now as a web page, and each of these, different questions are, you see how they have borders and the phone has a border. Those would be effectively islands or places in the DOM that need to be updated, but instead of redrawing the whole page, now the browser is capable of just, and the frameworks are, they can allow you to just, update the text nodes like directly in place. So it doesn't have to re-render the whole web page. It can just update one of these individual blocks as needed. You understand? So, but yeah, I wonder if that's what it's doing, or if it's just re-rendering the whole screen like really, 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 really fast. I'd be curious to know, but for another day, how do I delete this data? The book will show you how to do that, but for now, you can delete your app from the simulator. That will remove the data from the persistent storage that was connected to the app. What happens to the data after I stop running the app? The new person objects were saved to the persistent store, so if you quit the app, the data is preserved. Oh, that's weird. If you reopen the app, the data is loaded from the persistent store again and displayed on the screen. I don't have to call a save function to make the inserted data persist. No, Swift data will automatically persist your data for you. You can change this behavior though. You will learn how to do this later in the book. I wonder if that's what the devs do whenever, like there's a lot of apps that, like I hate using apps now that don't basically save for you just constantly in the background. Like maybe not every change, that might get expensive, but every 15 seconds or 30 seconds, something like that. And I mean, it's just cool because that's so much of this is like, it's, I suppose it just makes sense why the standard, for usability is so high, especially in the Apple ecosystem. Because you think about it, I mean, these tools that they're supplying for us as devs, I mean, I'm not saying it's easy, obviously. We're sitting here learning it for hundreds of hours, but by comparison, comparatively to other methods of writing applications, the tools that we have and the amount of work that's done for you, it's crazy. All right, 4 steps done. You've now successfully added data to your persistent store and have data successfully fetched and shown on the view. Uh, but you're saying if I stop this and how do I get rid of, or I guess I can't, but I want to build that again just to make sure it did save. Trust but verify. Also because I fucked the thing up earlier, so I'm not sure if I saw each step. Okay, where's that? I guess I could just kill. Let's do that. A real test. Okay, it's here. Wasn't lying. Okay. All right. So we did all that. Got a. that's pretty sweet. So that was the whole flow, and just in terms of initializing the app, what we need in terms of the schema, how to load the context, assign it to a view, and query it, and get it on the screen. Cool. All right. Summary. You created 3 files to get Swift data working. These first chapters were to help you establish a foundation to build on for the rest of the book. Yeah, so we had our model first. Here's our decorator, regular old class, 2 properties, an initializer, which we had to have. Normally we wouldn't, but in this case we have to for... There's some protocol we have to satisfy, but it was not painful at all. So we create the model, and then we use query macro to fetch data, which was coming from the model context that we created through dictation of the main app file, the entry point. So these two were both in the main entry point. Environment decorator, arguments, model context, name being a requirement, and then our query decorator. I really shouldn't call them that, but it's not what they're called, but it's what they, looks like a, what you call it, TypeScript or whatever. From the environment, so you can insert. And then we told Swift data that we wanted to add person model to the persistent storage and load it up into the environment. This also enabled @query to work. Okay, so our modifier under our view. So we call model container and then nominate the model that we want to work with, which was our person model. So kind of like the, yeah, I mean, actually just like the observable thing that we looked at, there was a, you know, you set up the thing on the properties, and then inside of whatever interaction point, we also nominate that as like the other end of it. Yeah. Good old Chris Latner, I think that's his name. Chris Latner, whoever, the author of Swift. I'm almost positive that's his name. But yeah, a lot of this, it's just so intuitive, you know? I mean, at least comparatively, this is great. I mean, I haven't felt like something was this straightforward to learn since, you know, like SQL syntax, because it's like English, you know? But anyway, I think we'll call it there for now, boys and girls. I'm gonna try to go find a chair. That's really all I'm missing, but my butt is getting sore. Pause. But yeah, that was a nice little run through. Yeah, I like this book a lot, and I like that approach to teaching. You know, show the whole thing, but very, very simple, and then just iterate over and expand on each component of it. So yeah, I like this a lot. But see, it goes to show, it's kind of interesting. Like, the very first book that we tried, just as a sample size, was the Big Nerd Ranch Guide, which I gush over, so you know I love that one. But it was good, you know? It was a good book. And it had a very similar teaching style, and then we tried 3 other books trying to learn, well, really just trying to find the modern way to learn SwiftUI and Swift data. But, you know, 2 or 3 of those were kind of eh, and then finally on the 4th, so, you know, it's hard to... It can be, I'll say. The others weren't terrible, but they were not of this caliber, for sure. So anyway, my only point is, they're out there. You know, good material is out there. Just sometimes you gotta work a little for it. But yeah, anyway, guys and girls, thanks for tuning in. We will be back tomorrow. Make sure you drop a follow. And also check out my other stream if you want to watch some oily nerd yell at other oily nerds in Halo. We're Diamond 4 now, so almost to Onyx. Come check me out. Otherwise, guys, see you tomorrow. Take care of yourselves. Go hydrate. Eat something nice for lunch.